Welcome everyone. In this video, we're gonna talk about equations of motion. But before writing equations of motion and solving problems in this video, at the end of this video, we will solve about 6 problems about equations of motion to get a high level of understanding. But before that, we have to define acceleration. Let's revise acceleration. Acceleration means rate of a change of velocity. For example, if you have a car and this car was moving with initial velocity 10 meters per second, then its velocity increases to be, let's make it VF, which is final velocity, 20 meters per second. So the velocity increases with 10 meters per second within a time 2 seconds. In this case, we say that the car is accelerating because the velocity increases within this time, which is 2 seconds. So acceleration is the rate of a change in velocity. Okay, and if you want to calculate the acceleration here, acceleration equals final velocity minus initial velocity over change in time. If you want to calculate the acceleration in this case, it will be final velocity, which is 20, minus initial velocity, which is 10, divide change in time, which is 2 seconds. So acceleration here will be 20 minus 10 equals 10 over 2 equals 5 meters per second squared. Okay, so why I revised for acceleration? Because equations of motion are applied for any body moving with acceleration. Okay, equations of motion are applied for anybody moving with acceleration. Okay, so what are the equations of motion? We have 3 equations of motion, and in some books there are 4, but no worries, just 3 equations of motion. We can solve all the problems. So what are these equations of motion? The first equation is VF equals VI plus AT. This is the first equation. The second equation is D equal VIT plus half AT squared. The third equation is 2AD, 2 is the constant, AD equals VF squared minus VI squared. So let's explain each symbol I have right. VF, let's write them in this side. VF means final velocity. Okay, so VF, we have VF in first equation and in third equation, but in this case is sorry, Vf. Okay, Vf is squared. Then Vi is the initial velocity. Initial velocity. Vi, we have Vi here and here. A means acceleration. You will notice that acceleration is written in the three equations. D means displacement. Okay, D is written in the second and third equation. T means time. T means time. So the question here, when we will use the first equation or the second equation or the third equation? When we will use each of them? I will give you an answer. You will use the first or second or third equation about two things, which are givens and unknown. About or according to what is a given you have and what are the unknowns you should find, you will decide which equation you will use. Okay, to deep the understanding or to get higher understanding, we will solve some problems together to know how can you decide if you will use the first or second or third equation. Here we have some examples. First of all, you have to read the equation or the problem. You have to read the problem very carefully. Then you have to determine the unknown and the given. An object has started motion from rest. If you have a body started motion from rest, so you have the initial velocity. The initial velocity here is 0 because you was starting from nothing, from rest, so Vi equals 0. At uniform acceleration, so you have acceleration here 2 meters per second squared. Take in consideration that you have uniform units. For time 10 seconds. 10 seconds is the time. 10 seconds. So the unknown is final velocity. You need final velocity and the distance moved or the displacement. Okay. So in this case, you will use more than one equation. As we studied in the previous slide, you have three equations. The first equation is Vf equal Vi plus At. Let's write this equation here. Vf equals Vi plus At. So as we determine the given, you have Vi, you have acceleration, you have time. So you can use this equation to solve the first unknown or to get the first unknown, which is Vf. So final velocity here equals Vi equals 0 plus acceleration is 2, time is 10, so Vf equals 0 plus 2 times 10, 2 times 10 equals 20, Vf equals 20 meters per second. So this is the first unknown. Then the distance moved, you can here you can use any of these equations. Why? Because you have a time, so you can use the first equation and you have the initial velocity, or you can use the third equation, okay, to get the displacement. But it's more easily to use the second equation, which is d equal vit plus half at squared. So by using the second equation, d equals vit plus half at squared. Okay, so d equals vi equals 0, so you can cancel this side, plus half acceleration equals 2, time is 10, but you have square, so it is 10 squared. 2 will be cancelled with half, so you have 10 squared, which is 100, and the unit here will be meter, because you have the acceleration meter per second squared, so, and time in second, so this displacement will be in meter. Okay, I hope that you understand what we solve. The second problem here, a car was moving at 20 meters per second. So this is the initial velocity. Initial velocity here is 20 meters per second. When the brakes were applied, it decelerates uniformly at 2 meters per second squared. As we know, or as we have studied before, if you have deceleration, so acceleration here will be in negative sign. So acceleration will be negative 2 meter per second squared. So you have two givens. You have initial velocity and acceleration. Okay. Let's show. So what are the unknown? The first is time taken to stop. Someone asked, so where is the final velocity? The final velocity here in the first unknown. Time taken to stop. To stop means the final velocity equals 0. So if you want to get the time, you can use this formula, A equal Vf minus Vi over time, or the first equation, because this formula is the same as the first equation, Vf equal Vi plus At. As you like, if you used this or this, the same. Vf equals 0, Vi equal 20, acceleration would be a negative sign, so it would be negative 2, the time that we need. Okay, so 20 will go to the other side with negative sign, negative 20 equals negative 2t. Negative will cancel negative, 2 will go to the second side with divide, so t equals 20 over 2 equals 10 seconds. For the second unknown, distance moved during braking. Okay, so here we have used the first equation, and the second unknown we can use both of second or third equation, because here we have Vi, we have acceleration, we have final velocity, which is stopping, which is 0, we have time, so you can use both of them. Okay, distance moved during braking, so it will be, we can solve by both of them here in this example. D equal, the second equation, D equal VIT plus half AT squared. D equals VI equals 20 times is the time is 10 plus half times acceleration is -2. You can make a bracket here to avoid confusion, times t squared, which is 10 squared. Be careful, the square, that power 2 here is for 10 only, not for the whole bracket. So equals half will be cancelled with 2, so we have -10 squared, which is -100. 20 times 10 will be 200, so displacement is 200 minus 100 equals 100 meter. Let's solve the same problem with the third equation. The third equation says 2AD equals VF squared minus VI squared. 2 times acceleration is -2 times displacement that you want to get. VF is 0 because here he said that the car stopped. 0 minus VI squared, which is 20. V20 squared. 2 times -2 equals -4D equals 20 power 2 equals 400, and we have negative sign, so it would be -400. So displacement equals -400 divide -4, it will be 100 meter. Okay, let's move on to the third problem. A car is accelerated uniformly from initial velocity, so you have initial velocity 15 meter per second to reach 20 meter per second, so this is a final velocity 20 meter per second within 2.5 seconds, so this is a time 2.5 seconds. So you can know the unknown or the quantities from their unit. If you have meter per second, so you are talking about velocity. If you have second or hour or minute, so you are talking about time. So here find the distance moved by the car in this interval. So we will you don't have acceleration, although he didn't want acceleration, but I need acceleration to find the distance. As you know, the three equations, all of them, we have acceleration. So to use any of these equations, you have to have acceleration. So first, I will get acceleration by this formula or by first equation, as you know, as you like, Vf minus Vi over delta t. So acceleration, it would be Vf is 20 minus Vi is 15 over time, which is 2.5. So it would be 20 minus 15, 20 minus 15 is 5 over 2.5, so it equals 2 meter per second squared. 2 meter per second squared. You have to avoid confusion, you have taken consideration to substitute correctly. Vf here is 20, Vi is 15, not the opposite. If you write the opposite substitution, the answer will be a negative sign and it will affect your final answer. So we have initial velocity, we have final velocity, we have acceleration, we have time. So as you like, if you want to use the second or third equation, as you like. If we use the second equation, d equal VIT plus half AT squared. Let's substitute. D equals Vi equals 15 times T, which is 2.5, plus half, acceleration is 2, time is 2.5 squared, 2.5 squared. 2 will cancel with half, so you have 15 times 2.5 plus 2.5 squared, 43.75 meters. So this is the final answer. You can try to using the third equation and write your answer. Please don't forget to write the unit after any answer. After each answer, you have to write the unit. Number 4, a car started motion from rest. As we said before, if the car moved motion from rest or started motion from rest, so the initial velocity equals 0. At uniform acceleration, acceleration is 2 meters per second squared, next to moving a distance of 100 meters. So the distance here is 100 meters. The driver turned the engine off. So here the car will slow down. The car stopped. Okay, in this problem you have two problems in one problem. Let's draw this problem. Okay, first the car started motion from rest, VI equals 0, and moved with acceleration 2 meters per second squared for a distance 100 meters. Then the car or the driver turned the engine off, so you will start another trip, but you will slow down. Okay, so you don't have the final velocity here. The final velocity here in this trip will be initial velocity in the second trip. The car stopped. Vf equals 0 after 5 seconds, so the time here is 5 seconds, but the time starting from turning the engine off till the car stopped. Find the acceleration and the distance moved during these 5 seconds. So here he need to know the acceleration in this period and the distance. Okay, first of all you have to calculate the final velocity in this period. You have initial velocity, you have acceleration, displacement, and final velocity. You will use the third equation to AD equals Vf squared minus Vi squared. 2 times acceleration is 2 times displacement equals Vf squared minus 0. So the VF squared equals all of that. 2 times 2 times 100. 2 times 2 equals 4 times 100 equals 400. So VF squared equals 400 by using square root. You will square root the two sides, so the VF equals square root 400 equals 20 meter per second. So the VF here is 20 meter per second, and at the same time the VF for this period, it will be the VI for the next period. So the VI here is 20 meter per second. In this period we have started with V 20 meter per second, and time is 5 and VF is 0. So at this moment we can get the acceleration and displacement. You can get the acceleration from this formula. Acceleration equal VF minus VI over change in time. VF is 0, and obviously the acceleration will be a negative sign. Why? Because the car is slowing down, and as we said before, when a body is slowing down, so the acceleration will be a negative sign. Negative 20 over time, which is 5. Negative 20 over 5, negative 20 over 5 equals negative 4 meter per second squared. Okay, so the acceleration is negative 4 meter per second squared. So this displacement, you can get the displacement from the second equation, the equal, or from the third equation, as you like, the equal VIT plus half AT squared. So the equals VI equals 20. Not this, no. I'm talking about this period, okay? I'm talking about this period. So VI here is 20 times time, which is 5, plus half times negative 4 times 5 power 2. You can use a calculator and making these numbers inside brackets. Displacement here equals VI equals 20. Okay, 20, not this VI. I'm talking about this period. So the initial velocity here, it will the start of this period, which is at the moment of closing or turning the engine off. 20 times time, which is 5, plus half times negative 4 times t, which is 5 power 2. Okay, 20 times 5 equals 100. Plus half times negative 4 equals negative 2. Negative 2 times 5 squared equals 50. And this is a negative sign, so it will be 50 equals 50 meter. 50 meter. In the last example, an object falls from 5 meter high above the ground. Find its velocity when reaching the ground and the time taken. So the sixth example, I cannot teach it now, but maybe I will solve it in next video. If anyone needs to solve the sixth problem, just comment. An object falls from, okay, we have for example, we have a building. An object falls objects like a ball. When I say falls, object falls, so it will fall from rest. So Vi here equals 0. From 5 meter high, so this is a displacement. The height here is a displacement above the ground. Find its velocity, so he needs final velocity. This is unknown. When reaching the ground and the time taken. Here he needs the time taken and the final velocity. So the acceleration here is the gravitational acceleration, which is 9.8 meters per second square. As when the body moves or falling, it will acquire acceleration as its velocity increases with time. Okay, when you let anything to fall, so it will acquire acceleration because of the gravity. So the acceleration here will be the gravitational acceleration. So we have acceleration, which is 9.8 meter per second squared. You can use the equations of motion. As we said, you can use the first equation, Vf equals Vi plus At. So where is A? I have G, so you can replace A with G. No worries. Okay, final velocity and initial velocity is 0 plus 9.8 times time. So you don't have both of them. So the first equation, doesn't work. Okay, first equation here doesn't work. So according to your given and unknown, you can use the second equation, D equal Vit plus half At squared. D here is 5, Vi equals 0, so you can cancel this amount. 0 times something is 0, anything is 0. Half acceleration is 9.8, time is power 2, which is unknown. So T squared equals 5 over half. Okay, all this value you can move it by division to the other side. You can calculate it. So the time here is 1.02. By using square root answer, it will be the same. So the time here, by making square root, time here is 1.01 second. Okay, approximately the same number. Okay, so you have time 1.01 second. Let's get the okay, 1 second. Let's get the final velocity. You can get the final velocity by this equation, Vf equal Vi plus At, which is the first equation. Vf equals Vi equals 0 plus acceleration, which is 9.8 times time, which is 1.01. So final velocity would be 9.89 meter per second. I hope that you get benefit from this video. Please, if you get benefit from this video, please comment to know if the video is beneficial for you.